Okay, we're almost close to back on schedule. Not bad for a bunch of whale people. We're hard to schedule like the whales are. We are very pleased to have Sandie O'Neill from the Washington Department of Fish and Wildlife. Sandie's work has been studying toxic contamination in everything from the little herring to the big orcas and the salmon in between. And a lot of her work that she has done has become increasingly more important as we find our southern resident orcas being in more and more trouble, and the toxins playing a big part in that. So thank you. I won't take up much of your time since we're behind. She will show you that she's another Wonder Woman that we have on the whale side.
Good afternoon. It's a beautiful sunny day, and I appreciate you all being inside instead of outside scouting for whales. But anyway, I do work at Fish and Wildlife, and I work in a contaminant unit. We call ourselves T-BIOS. It's a long word, toxic-focused biological observing system, and that just means we measure contaminants in biota. We don't really care if it's in the sediments or water, if it's not getting into the biota or doing something to the biota. So that's sort of why we call ourselves T-BIOS. And as Susan said, we've been around. I think I got hired in this program in 1989, and I've been there the whole time except for 4 years that I went to NOAA and I went back to the same program. So we have measured contaminants in everything from plankton, herring, crabs, shrimp, English sole, juvenile Chinook, adult Chinook, coho, adult coho, etc. I've actually not measured contaminants in killer whales, but I've co-authored with people who have. So I don't actually work on whales per se. We also have one of the vital signs, and previous speaker was talking about some of the indicators of the health. So we have an indicator of the health of Puget Sound, which is contaminants in herring, English sole, and juvenile Chinook salmon. Many of you know, of course, that contaminants have been listed as one of the major threats affecting the recovery of southern resident orcas. But actually, I'm not really going to talk mostly about contaminants and what they do to orcas. The other factors, other threats that affecting them, of course, are noise and prey availability, we just heard about. And really what I want to talk to you about today is not all the nasty things that contaminants do, but I want to talk to you about a little bit of the upside of contaminants and how they can be used as a tool to help you figure out the foraging habitat, which is basically all the area where the whales feed. And so how do we find out about what whales eat or their foraging habitat, where they eat? And we need to know that in order to protect them. We're talking about protecting Chinook salmon. Which Chinook salmon populations do we need to protect, for example? So one of the main ways that we figure out what they eat is by looking at feeding events. And there's a lot of work that gets done by Brad Hansen and others at NOAA to do just that. They go out and observe the whales. They scoop in when they see them feeding. They pick up prey fragments and they say, ooh, that's a scale from a Chinook. Ooh, that's a scale from a coho, etc. So that's one way that they do it. They also can scoop up the poop of a killer whale and do fecal analysis, and so they can, based on the genetic identity of the fecal fragments, they can tell us what species are eaten. And also there are things like when whales wash up on the beach, you can look at their stomach contents. So all of these things are very useful, but a lot of the work that for the prey fragments are limited to the summertime. There's some winter stuff, but most of it's taken in the summer when they're feeding in and around the Salish Sea. And then when you do look at gut contents from a deceased whale, you have to ask yourself, well, how representative is that? The whale was sick, it's died. The foraging habitat as well, you can have direct observations. Again, they're mostly limited for the winter because you have to go out onto rough waters to try to find the whales and see where they're feeding. So you can observe them mostly in the summer. You can also tag whales and get acoustic recordings, so then you know where the whales are. You don't necessarily know if they're feeding there, but you know at least where they're traveling. And again, many of you people probably know more about this than I do, but this is sort of a quick synopsis. I'm sure there are lots of things that I'm leaving out here, but this is sort of a general understanding about what the scientific community knows about a whale. So we know that J, K, and L pod feed in and around the Salish Sea in the summertime. We know that J pod spends a little bit more time here in the winter. They eat a lot of Chinook when they're here, mostly in the summer months, and then as we move into the fall, the Chinook populations drop off a little bit. We start eating some coho, and then later in the winter, there's some more chum that are eaten. The fish that they're mostly eating in the summer months, the Chinook, they're mostly Fraser River and some Puget Sound, mostly. Then what are they eating when they're not in the Salish Sea? So we have, as they're going up and down the west coast, again, NOAA Fisheries has done most of this work. They know that K and L feed further south down the coast. The killer whales will feed as far north as sort of central BC coast all the way down to California. But the K and L tend to spend more time feeding further south than J pod does. Chinook are still consumed in the winter, but they are also finding that, then these are basically based on prey fragments and things like that. They know they're still eating steelhead, they're eating lingcod and some other miscellaneous fishes. We still know that, again, based on these fecal samples and scale fragments, that they are still eating some Columbia River Chinook. About 50% of what they're eating in the winter months are Chinook from the Columbia River, but the other 50% are mixed stocks, a whole bunch of different stocks from up and down the west coast. So now I'm going to switch over and show you how I can use contaminants as a chemical tracer. In particular, one type of contaminant is persistent organic pollutants to help figure out what whales are eating or where they're eating. Okay, so these persistent organic pollutants, or they're called POPs for short, are man-made chemicals for the most part. They're things like PCBs, the flame retardants, PBDEs, chlorinated pesticides like DDT, and another one that I'll talk about a little bit is HCB, which is hexachlorobenzene, which is again a pesticide. These things dissolve easily in animal fat, and once they get into the animal, they're not easily metabolized, so they tend to accumulate over time as an animal ages. And then they also biomagnify up the food web. So whatever is in your prey becomes into you. So a Chinook salmon gets its contaminant from its herring, and then when killer whales eat a Chinook salmon, you get the passage of those contaminants up through the food web. The most important thing that you need to know for this talk, though, is that there are global distributions of, these things are globally distributed. You can find these contaminants all over the world, but there are no hotspots. And that's just an area where there's more of them than in other areas, okay? So, so scientists other than me have long ago figured out that because these marine environments have very distinct patterns of these POPs, these persistent organic pollutants, they'll go into the environment, and those environments, the water, the sediments, also get that same kind of concentrations, okay? And so the Puget Sound is known as a PCB hotspot, whereas the west coast down in California is known as a DDT hotspot. And so animals that are foraging in those regions pick up those contaminants, and so you can tell just by looking at the proportion of different kinds of POPs where that animal has been feeding. So think of these little pie charts as like, this is the pie chart showing all the food that you've eaten in your lifetime, okay? And I'm breaking up all the pops that you've accumulated into a pie, and I'm saying what proportion of those pops are PCBs, and what proportion is DDT, etc. And so if you were looking at that pie or that little fingerprint for something that feeds in Puget Sound, you would see a lot more PCBs relative to those other pops. But if you were an animal that spends a lot of time feeding down around California, you'd have a pie or fingerprint that had a lot more DDTs in it. So that's the essence of what I'm going to talk to you about in more detail. So what I want to do is show you how we can use pop fingerprints, these contaminant fingerprints, of species that we know something about in terms of where they feed and what they feed upon, and start comparing fingerprints of animals that we know something about with fingerprints of animals like southern resident orcas that we know less about, to see if we can figure out over their life history where are they spending most of their time feeding. So this is basically you go out and you measure the contaminants in the animals. For Pacific herring and Chinook salmon, we use the whole bodies. And for southern residents, we only use the biopsy samples from the blubber, so they're not exactly comparable. And then you collect the fish and the blubber samples from throughout their feeding range. And then what you do is you measure those contaminants. You can see on the left here, or whatever my left is, am I doing this right? Yeah. So this is when you take a big Chinook salmon. We got some Chinook salmon from the Skeena River, and they were almost as tall as I was. But I needed about 2 grams of tissue for analysis, okay? But I had to grind up the whole thing because I was trying to get something that was representative of what a whale would eat. So they get ground up in these big food grinders and then mixed up, put in a little vial. And then Gina Ulitala, my co-author at National Fisheries Service, would do her magic and tell me what kind of contaminants were in them. So I'm going to start to show you some data on herring populations, and it'll go much more quickly, but once you get the patterns, they go along pretty quickly. So we sampled everything all the way from Quaidabai, or Queen Charlotte Islands, as they used to be called, the BC West Coast, West Coast Vancouver Island, Puget Sound, all the way down into, we did get some herring from actually right inside, they were spawning in San Francisco Bay. Okay, and so if you start to look at the contaminant levels, this is a PCB, okay? And as you can see, as you come down the coast, there's hardly any PCBs up north, and as you come down, we get a few more PCBs. San Francisco Bay, they got some PCBs. But Puget Sound is a totally different beast, okay? We have, in the Strait of Georgia, we have, or up near the Strait of Georgia, northern Puget Sound, we have fairly low levels, but once you move into the central and southern part of Puget Sound, we have some of the most contaminated herring globally. They're more contaminated or as contaminated in Puget Sound as they are, say, in the Baltic. And that's because Puget Sound is a deep inland fjord. You have to think of Puget Sound like a big bowl. And we have an expression, my colleague Jim West and I would say, what gets in the sound stays in the sound. So so places like San Francisco are no more pristine in terms of their PCB usage than we are in Puget Sound, but San Francisco's bay is a big flat open area and it flushes very well. We have this beautiful deep inland fjord, which is why we have all these species that live here year round, and so the contaminants get into our marine waters but they don't get flushed out. So that's one of the reasons that we have very, very high levels of PCBs. We also have, so you can see we're definitely a PCB hotspot on the West Coast. When you look at DDT, this is chlorinated pesticide, both PCBs and DDTs were banned in the 70s. So these are things that have been in the food web for a very long time. And you can see that even though we have some PCBs, that it's actually California that's still a bit of a hotspot for DDTs, and no surprise there, okay? I'm not going to show you some other chemicals, I just wanted to show you a couple. I'll show you another contaminant as well in a few minutes, but I just wanted to get onto the idea of what do these fingerprints look like. So again, I'm going to take all these animals, and each sample gets plotted on the chart here. So think of this as every little X here or plus sign, that's a sample, okay? And every sample has one of those little pie charts. And the little samples that are closer together are more similar. And if the further apart they are, the more dissimilar they are. So this shows you, here's our Puget Sound right here. Here's our Puget Sound herring. And they're all clustered close together. And they have a high PCB fingerprint, lower amounts of DDT, and lower amounts of hexachlorobenzene. But if you go to something like the Queen Charlotte's or something like that, these fish have some hexachlorobenzene, and they have like no hardly any DDTs, no flame retardants, and a little tiny bit of PCBs. And if you go down to California, they have, here's the San Francisco Bay ones. So they have, again, a much higher DDT, lower amounts of PCB. So and what you can see is there's very little overlap between these herring populations. They're very discrete little units. And herring don't move around very much. They have small migratory movements, but it's not like a Chinook salmon that can migrate over large distances. They have very localized distributions. So we think of these as the fingerprints of herring as a place to anchor where like if you look at that fingerprint, you know where they are on the coast, where they're feeding. We know that these San Francisco Bay herring don't go much further beyond San Francisco Bay to feed, okay? So now I do want to switch over and show you some Chinook salmon and some of their contaminants. So here's some PCBs. Just a second, I want to go back here. So we, again, sampled along the coast several areas along here that are mostly Fraser River populations, Puget Sound, Columbia River. I'm only going to show you data for Columbia River Falls, not the springs, and if somebody wants to ask me about that later, we can. And then some California ones off the coast of California. So, no surprise here, again, we get large amounts of PCBs in Puget Sound Chinook salmon. In fact, they're about 4 times or so more contaminated than other Chinook salmon up and down the west coast. None in this data set, but we've looked at Chinook from other places, and those from Alaska are clean as a whistle. Okay? And again, Puget Sound, same kind of issue. It's a big inland fjord. We have a lot of our salmon, about a third of our Chinook salmon, spend a good bit of time residing and feeding in Puget Sound in the winter months rather than migrating out off the coast. And consequently, they pick up a lot more contaminants. They're eating all those contaminated herring I just showed you. Okay? When you look at DDTs, again, a very similar pattern to what you saw in the herring, that the California Chinook definitely have the highest levels of DDTs. The Columbia certainly has some as well. There's a lot of DDT use in and around Columbia, and so that the contaminants aren't necessarily accumulated in the whales when they're in the river feeding. They're mostly accumulated in the ocean because that's where all their growth is, and that's where they're picking up all the contaminants. But all the contaminants that go into the waters of the Columbia flow out into the ocean, and so you get a very contaminated food supply. There was a very large DDT facility in Southern California called Montrose, and they released a lot of DDTs, and so they basically contaminated most of the food web in Southern California. This is a new chemical that I haven't shown you before. This is hexachlorobenzene. It is a chlorinated pesticide. It doesn't get used much in North America. And in this case, you can see the concentrations are quite low. They're up in 5 nanograms per gram wet weight, so pretty low concentrations. But places like the Skeena River and some of the Fraser stocks that migrate quite a bit far north have higher levels of hexachlorobenzene. And that's because it's actually atmospherically transported from Asia. It gets into the food web in more northernly distributed marine food webs. Okay? So, now I'm going to make these little fingerprints and show you what they look like. Again, each of these little dots represents a single fish, okay? And I'm going to start to color code these to show you the populations that are close together, so you can see how they look. So here's the ones from Central California. These were caught off point, raised in Southern California. They're mostly San Joaquin stock, and they're not really, they're all pretty close together. And what we know about them from other studies is that they come out from these rivers and they migrate northward towards the coast of California. Some of them might go to Alaska, but not many of them. Most of them are distributed basically just off the coast from where they left their river. Oops, I went back. So here's the Skeena River up north. Again, very, very different fingerprint. These fish are out in the Bering Sea where they're growing and feeding, so they're picking up very few contaminants. It's mostly a hexachlorobenzene signal. Here's some Puget Sound resident Chinook in white, and some. Here's some Puget Sound Chinook, and I have a hearing aid and it's Bluetoothing and ringing in my hearing aid from my phone, which is really annoying. I can't concentrate, sorry about that. I'm old. I dyed my hair, really much older than I am. So we have, again, we have resident Chinook salmon, which I'm showing you in white, and then these are fish that were caught in Puget Sound in the resident, so I know they're resident because they're in Puget Sound in the winter when most Chinook should be out on the coast. The pink little circles are all the Puget Sound that are caught, the Puget Sound Chinook that are caught going up a river. And so once you catch them in a river, these are like tribally caught fish, you can see that they have some of the little pink circles overlap with the white ones. So some of those resident fish go up the river and spawn as well. So so you can see that the distribution of Puget Sound Chinook is quite broad. They overlap with a lot of the other fish that are out there. The Fraser, which you can't really see very well here. Here's some of the Fraser ones up here, and these are the green ones are the Columbia River fall Chinook. And so you can see the Puget Sound fish overlap a little bit with some of the Columbia River, and they overlap a little bit with some of the Frasers, and not many of them are getting out where the Skeena River fish are, okay? And there's very little overlap with California. If there was a lot overlap, it would mean they would coming out of Puget Sound and going south off the coast, and that really doesn't happen very much. But Columbia River fish do come out of the Columbia River, the Chinook, and some of them swim north and some of them swim south. So you can see that the Columbia River fish are getting closer to overlapping with California. And again, this isn't all the different populations that are out there, but it's a fair number of fish from different stocks. So most importantly, these fingerprints are very consistent, or the distribution of these things are very, very consistent with what we know about the marine distribution of these animals. So when I first created these contaminant fingerprints, I showed them to my husband, who's sitting here. His name is Tom Quinn, and he studies salmon and he knows a lot about salmon. I think he spoke to this group a couple of years ago. And I showed him this and I asked him what this looked like, and he said, I don't know. He didn't know it was the whale did, and he said, I don't know. Oh, that's the Chinook contaminant. He said, I don't know, marine distribution of salmon. And so it's really, really true. Lori Whitecamp from NOAA has a fantastic paper where she describes the marine distribution of salmon. So these fingerprints are matching up beautifully with what we know about where these fish go in the ocean. Okay? So now, this is what you came to see. I only have one slide of data that has whale information, so you get one slide. So I'm going to start to compare I'm not going to do that yet. I'm just going to overlap the herring and the Chinook just to show you more quickly what they look like when they overlap. So so the circles that are, I've just got the herring and the Chinook on the same graph here, and the Chinook are in the blue and the herring are the little crosses, and you can see I've color-coded the herring first, and oops. Yeah, so now I'm just going to show you how they overlap. So here's California Chinook and California herring. You can see that there's not perfect overlap, and that's because the Chinook aren't feeding in San Francisco Bay, but they're feeding along the coast there, right? So here's Puget Sound herring and resident Chinook. Perfect overlap. You can't make this up. The BC North Coast, they are not really overlapping with the herring that are found there, and that's because the salmon at this point are far offshore from the coast, and the herring are still closer to shore, but they have a signal that's more similar than some of these other populations. I just want to show you, this is a very confusing one, but these pink ones, I've now colored all the herring blue. I've recolor-coded all the Chinook back to blue except for the Puget Sound, which are shown in pink. Okay, those circles, that's all Puget Sound. And I've just shown the herring from all these locations. And you can see that Puget Sound, as a population, it feeds on herring that stay in the Sound. The Puget Sound Chinook are feeding on some from the Strait of Georgia. They're feeding on herring from the west coast of Vancouver Island and further north. So they're overlapping a lot with different herring populations. So they're bringing in their contaminants from a very broad area. Okay, this is I think I just missed the other order. So now I'm going to show you some of the contaminant fingerprints between orcas and Chinook. There we go. You know what? This is the right slide presentation. Sorry, these are out of order. Here's again, remember that the Chinook have these regional distributions up and down the coast. The orcas have a much more wide-ranging, so the idea is that we're going to look at the overlap, and so wherever you see overlap, it shows that the orcas are feeding in that same food web. Doesn't necessarily mean they're feeding on Chinook per se, but it means that they're feeding in the same places that the Chinook are feeding in, okay? So again, this is the fingerprint I showed you a little bit ago for the salmon, and here's the slide you wanted. I've overlaid this is K and L pod here, so these little asterisks here in green for K and L, the orange for L pod, you can see that those fingerprints of the killer whales overlap significantly with Central California and some of the California. They don't overlap at all with the Fraser River. And they just don't. And then I also showed you that, here's the little, I don't know if you can barely see them, these little asterisks here in blue, that's J-pod. And J-pod overlaps also with some California, but it's much broader. Some California, some Columbia River Chinook, and a lot of Puget Sound. And again, not a lot of Fraser. Now we all know that these animals, or these orcas, eat Fraser River Chinook when they're here, but these contaminants are accumulated over their lifetime. And over a course of a year, you've got 12 months, right? These whales are going to be feeding. They're not feeding. They might not get enough of their Chinook, but they're still feeding. So what are they feeding on for the 10 months of the year when they're not in the Salish Sea? And so it tells us that although they feed on Fraser River Chinook in the summertime, that's not where the bulk of their food supply is coming from over the course of a year and over the course of their life cycle. So they're important in the diet, they're not important in the diet. But if they ate mostly Chinook and they got most of their food supply from Fraser River, they would have a contaminant fingerprint that had much higher levels of hexachlorobenzene and hardly any PCBs. So anyway, it gives us a little bit of perspective for where they're feeding over a course of a year and the course of their lifetime. So takeaway messages are that jade pod whales, their fingerprints overlap with those of Chinook from Puget Sound. I didn't show the data, but I have some newer data that I haven't plotted yet for some Harrison River Chinook, which have a much more local distribution unlike some of the other populations. So it does overlap with some of those. Also the Columbia River, and that suggests that the whales feed mostly in the same regions that those salmon populations are feeding. And so there's substantial proportion of their prey come from those regions. And I just say that they have a sort of a Salish Sea and Columbia River signal in their diet and in their contaminant fingerprint. K&L pod, those whales are overlapping more with Chinook salmon from California and the Columbia River. And they also, that means that a substantial proportion of their prey are coming from those regions, same regions that the salmon are feeding in. And again, this fingerprint is more of a California and a Columbia River signal. So the Chinook stocks from California, Oregon, and Puget Sound are likely playing a pretty major role in food supply for orca whales. I'd say likely because if you have a coho that hangs out around the coast of California, the coho will look just like a Chinook. I can't tell the difference. So with the fingerprint, I just know they're feeding in the same area. But so those populations, though, I think we're talking about recovering Puget Sound Chinook. We shouldn't forget that we have to recover Columbia River Chinook, and we also need to think about some of the California populations as a food supply for K&L pods. And this is just going back to my contaminant self. Coastwide reductions in toxics are going to be needed to lower contaminant exposure for killer whale. And anything that we do in Puget Sound, the Governor's Task Force has come out. I was on the work group that on the contaminant part of it. And anything that we do in Puget Sound is going to provide more benefit to jade pod. So it just means that we need to reach out to other agencies up and down the coast to do their part to control contaminants. And finally, I just want to leave you with the idea that these contaminant fingerprints are also useful and may help elucidate redistribution and foraging habitats for other species and populations that we know little about. And with that, I can take any questions. Yes.
I'm just curious, over what time frame were the samples collected for the orca?
For the orca, they go back from the mid-90s, I think. Yes. And the whale, the salmon samples are from 2000 to 2010. It's quite a bit of overlap. The herring were all about 2006, I think. Yes. Well, they're outlawed, but they don't break down. So it's really hard. Once they're in biota, it's really hard to get them out. But if you look at herring in Puget Sound, we measure 3-year-old herring. So, and it means when I look at 3-year-old herring and there's no change in the time trend of PCBs over time, it means that there's an ongoing source. And so whenever there's a storm event, there's stormwater, think of all the built environment, every building that has caulk in it has PCBs and caulk. So there is new information and coming out about how much caulk has PCBs, and so there's new money set aside to remove caulk from buildings called retrofits. Think about storm drains, the insides of them get caked with all kinds of crap, literally. And so the PCBs are those for cleaning out storm drains. So you can do things to remove ongoing inputs into the food web. It will take quite a while, but they will eventually make an effect. We're seeing declines in PCBs and herring in the north part of Puget Sound because the tap is turned off, but there's not really an ongoing source. But in the central and southern part of Puget Sound, there's no change. So we're not doing enough to stop the flow in Puget Sound. Yeah. It's easier to, well, you can actually do some sediment cleanup. You can do capping or dredging. Dredging can sometimes disturb the sediments and resuspend the contaminants. But there are efforts underway to do contaminant cleanup in the sediments, and some of what's in the sediments gets up into the water column. We call it the pelagic zone. So all of these herring, Chinook, and whales, they're all eating up in the water column, far removed from the sediments. But think about a crab, right? A crab has all its eggs on the outside. She nestles down in the dirt, and when she releases her eggs, they go up into the environment and they become part of the plankton that the herring eats. So there's some sediment cleanup that can happen as well. Yes. Yeah, there are, I don't know maps, but there are basically, one of the recommendations in the Orca task force was to do better mapping of sediment cleanups and to accelerate the sediment cleanups, stormwater retrofits, and figure out where the stormwater hotspots were. So there are recommendations like that to address trying to do what additionally we can to reduce those contaminants. Yes? I'm the only person yes, there have been contaminants looked at in humpback whales. I know John Kalbakidis has done some, as well as Dave Herman when he was at NOAA. I don't know off the top of my head what those contaminant levels are or what the fingerprints are like. But if they're feeding for any extended period of time in and around Puget Sound, they will acquire that signal, but it just depends on how long. You are what you eat, but if you just have a snack, we all have a little snack that we're not supposed to, right? But if we eat healthy most of the time, we're okay. So, and I think wrapping it up, he says. So.